All right, so we're going to talk about math running records and kind of where they come from and so forth. I wrote a book on them in 2016, I think. And I wrote the book because I was a literacy person and I wanted to really figure out a system where we could figure out what was going on with kids in math, because we know where kids are in literacy. We give them a running record. And so I wanted to create the same thing in math. So I looked at the research and I came up with a math running record. Now, running records had been done for years, decades in the research, but the way they did it was a person would sit down with a PowerPoint and they would go 3 seconds at a time and they would ask kids questions about problems. And so we have all this data on what kids do when they see different problems, how they act, and interact with the problems. And so what I did was I gathered all that research and I made something that we could actually use in classrooms, because we don't have time to sit down with individual children and show them 90 slides and ask them questions about things.
Right.
So a running record is a system to collect consistent data across grades, grade bands, and schools on students' basic fact fluency power. Basic facts are defined as addition and subtraction, 0 to 20. That's basic facts. Now, there are all kinds of other facts, but these are basic facts. And then there's multiplication and division, and that's 0 to 100. And those are basic facts. So like 12 times 5 is not a basic fact. 10 times 5 is, right? So anything that has a product within 100 is a basic fact. Hold on for 1 second.
Okay.
Okay, so that's important about basic facts, because people will go beyond basic facts and they'll be like, oh, they don't know these, but those aren't basic facts. Those are extended facts.
Okay.
So why do we need them? Because oftentimes I'll ask teachers, well, what do they know? And they'll be like, oh, well, I think they kind of know they know how to add with intent, but there's no evidence. It's just kind of like hunches that people are going on and gut feelings. And you need evidence, right? So I borrow from Clay, who said, becoming neutral observers and watch children at work in systematic and repeatable ways. It has to be systematic. We have to have a way of collecting data that is systematic and repeatable and reliable. So when we look at math running records, they're taken to uncover specific strategy levels, right? And we know what those levels are. Like there's level 0 where kids have no strategy. There's level 1 where they're doing a lot of counting. There's level 2 where they are doing it in their head. There's level 3 where they've really started looking at numbers and depending on strategy. So they'll use what they know to help with what they don't know. So like kids that say, I don't know 5 times 7, but I know 5 times 5 is 25. And then I'm going to add 5 more and 5 more. Those kids are using what's called derived facts. And so they're at a level 3. Or kids that are like, I don't know 8 plus 7, but I know 8 plus 8 is 16. So 1 less is going to be 15. Or I know 7 plus 7 is 14. So 1 more is going to be 15. Those kids are using a level 3. It's called derived facts.
Okay.
And then on the running record, there's 2 other levels. There's 4M, which are kids that have memorized. And so those are kids that like, I don't know that one, right? They've memorized their numbers, but they don't know all of them. So if they've only memorized them, then they're tethered to their memory. And when it gives out, then they're stuck. Or there's kids that are like a level 4, not a 4M, but a 4, and they know they have profound number sense, and they know a lot of their facts automatically. And if they ever get stuck, they can go back to derived strategies.
Okay.
Those are like levels that you're looking for when you're giving the running record. You're trying to see what are they doing? Like, do they just say, I don't know that one? Like they have no strategy. They can't, like you say, what if I gave you some paper? They're like, I don't know it, pass. But kids that are like, oh, if I had some paper, I could figure it out, and they like draw pictures and stuff, those kids are like a level 1 at least, even if they're just counting, they at
Right.
least have a strategy, which is different from a kid that's like, I don't know it at all.
Yeah. Those are most of the kids, at least the upper grades that I'm working with. That's what I'm finding with them.
Okay.
I don't know. Everything is I don't know.
Everything is I don't know, right? And so we're trying
Yeah.
to move them. We're trying to move them to have strategies, right?
Right.
So to have an why do we do running records? So that we have an evidence-based system of data collection that can inform our instruction. So like what's really important about that is like, say you have kids where you're working on subtraction and you say, what's 8 minus 3? And the first child says like 83. Then you're like, okay, well hold on. There's an intervention that needs to take place and it has nothing to do with subtraction at this point.
Right.
So we have to go back and like build actual understanding of subtraction. We're not even working on procedure right now, right? But then you have another child that says 8 minus 3 is 11. So that's a specific error pattern, and you'll see that on the running record. So you're like, oh, they're adding instead of subtracting. They're using the wrong operation. So that's very different than the child that says 83. Right.
Yeah.
Or say you have another child and you say, what's 8 minus 3? And they go 8, 7, 6. So that is a miscount, right? And that's a procedural error. They're counting the 8. So you want to fix that, right? But that's different than the child that's adding or the child that's just putting those two numbers together and saying 83. So, you want to look at what is the thinking behind the thinking, what is the error pattern, so that intervention actually addresses whatever the error pattern is. That's really important about running records. Okay. So you're always thinking about what did they do? Not did they just get it right or wrong, but what did they do? Right. And then you take records to plan whole group, small group, workstations, individual work, homework, all of that. And so when should you do them? You do them at the beginning of the year, the middle of the year, and the end of the year. And then if you're like doing an intervention with an 8th grader who knows like not even addition, then you're going to do them more often because, you really have to lay some basic fact power and you're trying to do a lot. So you're going to, do more than you would with like a 1st grader. You know what I mean?
Right.
So it really depends on the students. You should do them. You can just pull kids aside. You do them wherever you would do like a regular reading running record. You do them at the end of 1st grade. So I have a kindergarten test, which is a counting test, but you don't really start doing running records until the end of kinder. And then you do them 1st and 5th, and then people do them in middle school for kids.
Yeah. Okay. So now I do have some middle school kids, but I definitely want to see where they're at because we were just doing multiplication bingo, which and I'm talking single digit multiplication problems that they should have known in 3rd grade and they don't know them.
Right. Right. So we got to close those gaps.
Right.
This is exactly what the running record is going to tell you is like where to start. Because a lot of times people will just give kids flashcards and say practice. That's not helpful, right? So you want to find out, like, do they know their 2s? Like the little boy that I tested this morning, he doesn't even know his 2s. He knows, oh, it's a double, but he's counting like 8 plus 8. He had to count 8 and then count on. So we can't say he knows his 2s. So we've got to go back with him and work on his doubles so that he can know his 2s. And then we would teach 4s, and then we would teach 8s, right?
Okay.
So like the order of how you teach kids to think strategically, which we'll talk a lot about more in a little while. So when we define fluency, it's not like who can get the answer fast. Automaticity, which means you can answer a problem within 3 seconds, is a result. It's an outcome of being fluent. It's not like the goal. Fluency is the goal. And fluency means that you are efficient, flexible, and accurate. Flexible meaning you know lots of ways. Efficient meaning you know easy ways, right? Easy, quick ways. So there, you could know lots of ways, but what is going to be the most efficient way? Right. So, and then kids need to be able to select the strategy that's appropriate for the math that they're doing. And they need to be able to explain what they're doing. So you'll notice on the running record in part 2, we ask kids to explain what they're doing.
Okay.
We want them to base their strategies in base 10 properties and the relationships between the numbers. So it's not just quick answers that we're looking for. We want kids to have number sense, and that's what we're trying to build. So computational fluency is multidimensional, right? And I want you to think about those 4 pillars, that it's flexible, accurate, efficient, and being able to select the correct strategy. So now we get to like, how does the running record help us build fluency? So what the running record does is it tests all those things. Are they accurate and instant? At the first part takes like a minute. Are they accurate and instant? The second part, you're looking for, are they flexible and efficient, right? And that takes like 8 minutes, 5 to 8 minutes. And then the third part is like 30 seconds, but you're trying to find out how they feel about math. Do they like division or multiplication or whatever you're doing? And what do they do when they get stuck? Because we need kids to have strategies for when they get stuck. And so when you're interviewing kids, there's a couple of things. You have to really know, like, what they're doing and watch it and record it. Because in an interview, kids will do things that they don't tell you, and they will tell you things that they didn't do. So they might, you might be like, how did you know that? And they're like, oh, I just knew it. And they sat there and counted on their fingers. Or you might say, how did you know it? And they say, oh, I skip counted, but they knew it automatically. So you have to really watch what they're actually doing, right, to record that. Like there's a little girl and I was like, what are you doing? She goes, oh, I'm skip counting. But I knew she was taking a really long time. I was like, oh, it doesn't seem like she's skip counting. And so finally I kept saying, I need to know, I need you to tell me out loud what you're doing. And so finally she was going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So she's counting by ones, but she's calling it skip counting, right?
Excuse me. Right.
And I'm like, oh, okay. So you really, you have to probe. And sometimes it takes kids a really long time to let you know what they're doing, but it's worth investing the time to find out, because that's where you're really going to be able to help them.
Okay.
So when you're assessing for automaticity, you're trying to see, like, do they know it automatically? Or are they thinking flexibly? So we ask kids questions like, if your friend was stuck, what would you tell them? To see if they actually have strategies. And we also want to know about their disposition. Students' facility in using basic math facts often has a significant effect on their confidence in themselves as mathematicians. So, I always ask people to think about, what are you doing right now in terms of math fact tests? And have you ever thought about assessing for disposition? Right. So that's really important. So that is the general overview.